You spent your first 1,000 days on this planet as a full human being, and you can't recall a single second of it. You opened your eyes for the very first time. You heard your mother's voice. You tasted milk. You crawled. You fell. You spoke your first word, and none of it left a trace in your adult mind. Most people think the explanation is obvious. Your brain wasn't developed enough. You were simply too young. But that answer misses the truth entirely. And the actual explanation is much stranger than any guess you've had. Because your infant brain wasn't failing to capture your life. It was capturing everything. But something systematically erased those files. In the early 1900s, Sigmund Freud was the first to give this mystery a name. He called it childhood amnesia. Yet we have rock-solid proof that babies do form memories. And take a famous experiment from the 1980s by psychologist Carolyn Rovee-Collier at Rutgers. She attached a ribbon from a baby's ankle to a colorful mobile hanging over the crib. The infants quickly learned that kicking made the mobile spin. And they loved it. They remembered. 2-month-olds held the memory for a couple of days. 6-month-olds kept it for weeks. So infant brains can learn, they can store information, they can retrieve it, but by the time you're an adult, those early memories are gone. For decades, scientists couldn't fully explain why. The first clue lies in your brain's architecture. The hippocampus, a small seahorse-shaped structure deep in your skull, is the engine of memory. It takes a lived moment, like a birthday party or a conversation, and encodes it as an episode you can replay later. In grown-ups, the hippocampus works smoothly with the prefrontal cortex to tag, store, and recall these experiences. But in babies, this system is still under construction. The highways between the hippocampus and the cortex are being built. Key areas like the dentate gyrus, which acts as a gatekeeper for new memories, don't fully wire up until somewhere between age 2 and 4. So your infant brain could create short-term memories. It just couldn't transfer them into long-term storage the way an adult brain does. But that's only half the puzzle. And what comes next is even weirder. In 2014, 2 neuroscientists in Toronto, Jocelyn and Paul Frankland, proposed a hypothesis that sounded bizarre. What if the very process that builds your brain is also what destroys your earliest memories? Here's what they meant. During your first years of life, your hippocampus produces new neurons at an astonishing rate. This is called neurogenesis. It's essential for wiring the circuits you'll use forever. But Jocelyn and Frankland suspected there was a price. Every time a new neuron integrates into an existing circuit, it disrupts the connections that were already there. The connections that held your memories. To test this, they ran experiments on mice. When they artificially increased neurogenesis in adult mice, those mice started forgetting things they had learned. And when they slowed neurogenesis in infant mice, those babies held onto their memories much longer than normal. Your baby brain wasn't too weak to remember. It was too busy growing. The results, published in the journal Science, pointed to a wild conclusion. Your earliest experiences weren't lost because they were never saved. They were overwritten because your brain kept building new rooms and demolishing the old walls in the process. But there's another layer, and this might be the strangest part of all. To form what scientists call autobiographical memory, the kind where you are the main character of a story you can replay, you need something most people never think about. You need a sense of self. You need to understand that you exist as a person, separate from the world around you. Developmental psychologists Mark Howe and Howe Courage argued in the late 1990s that this is a critical missing piece. Before roughly 18 to 24 months of age, infants don't recognize themselves as distinct individuals. The classic test is simple. Put a dot of rouge on a baby's nose and place them in front of a mirror. Before 18 months, they treat the reflection like another child. They don't touch their own nose. After 18 months, they do. They realize the person in the mirror is them. And that moment, the birth of self-recognition, closely matches the earliest age at which lasting personal memories can form. In other words, you can't remember being a baby partly because there was no you yet. Not the way you experience yourself now. There was no narrator inside your head packaging experiences into a story belonging to a person called me, which raises an uncomfortable question. If you had no continuous sense of self, and the brain that held your earliest experiences physically rewired itself beyond recognition, is the baby in your old photos actually you? Or is that someone else entirely? Someone who lived in the same body but whose mind was literally disassembled and rebuilt, neuron by neuron, into the person you became. There's one more piece: language. Developmental psychologist Catherine Nelson spent years studying how children form lasting memories. Her conclusion: language doesn't just describe our memories, it structures them. Before you could speak, your experiences were encoded as raw sensory impressions, sounds, textures, emotions, light. But without words to organize them, those impressions had no framework to attach to. Once children start speaking, and especially once they start having conversations with adults about past events like, remember when we went to the park? Their ability to form lasting memories improves dramatically. Language gives memory a skeleton. Without it, experiences are water without a container. And this isn't just theory. Psychologist Chi Wang at Cornell found that the age of your earliest memory actually varies by culture. In Western cultures, where parents frequently narrate their children's experiences, asking questions, telling stories, building personal narratives, earliest memories tend to start around age 3.5. Among the Maori of New Zealand, whose oral tradition places huge emphasis on personal history and storytelling, average first memories reach all the way back to age 2.5. In some East Asian cultures, where early childhood narratives focus less on the individual, first memories tend to start closer to age 4 or later. The culture you grow up in literally shapes how far back your memory reaches. So here's what actually happened to your earliest years. Your hippocampus wasn't ready to build long-term memories. And even when it started to, the flood of new neurons tore through the circuits that held them. You had no concept of self to anchor experiences to. And you had no language to give those experiences a structure that could survive. It wasn't one thing, it was everything, all at once. Where every human being who has ever lived went through this. Every person you've met has a black hole where the first years of their life should be. And the answer isn't that your brain was too simple, it's that your brain was doing something far more important than remembering. It was becoming you. And that required, quite literally, destroying the person who came before. If this blew your mind, hit like for Psychology Insights and stick around for more dives into the strange machinery of being human.